Now let me introduce the Model Toolkit. The Model Toolkit has two modules: Nano Predictor and Auto Nano ML for new nanomaterials prediction through machine learning approach. The Nano Predictor module maintains series of pre-developed machine learning models for different prediction tasks. For example, this is the Nano Predictor interface of the partial least squares regression model developed for nanomaterials with SA19 and SA20 data. It provides the model description, model-related literature, and an interactive scatter plot chart displaying the correlations between experimental and predicted values of the nanomaterials used in the modeling. The interface allows for downloading the model in pickle format, as well as the modeling datasets, including the nano descriptor data and the assay data in XLSX format. Users can locally prepare a nano descriptor dataset of new nanomaterials in XLSX format and submit it for prediction through the interface. Here, we will download and use the example nano descriptor file to illustrate the prediction process. Once the nano descriptor file is loaded and submitted for prediction, the interface will utilize the pre-developed model to perform the prediction and provide downloadable results, allowing users to assess these new nanomaterials. Moreover, a drop-down menu is added to the module for switching between nano predictor interfaces with different pre-developed models, making it easy for users to perform various endpoint prediction tasks. The Auto Nano ML module allows users to develop machine learning models through VNAs. Two machine learning algorithms, linear regression and partial least squares regression, are introduced for modeling in the module. For example, this is the initial Auto Nano ML interface for developing partial least squares regression model. The modeling process can be divided into 3 steps. Step 1. Uploading the descriptor and endpoint datasets in XLSX format. Here, we will download and use the example nano descriptor and endpoint files of some nanomaterials to illustrate the modeling process. Step 2. Choosing a descriptor standardization method, either standard scalar or min-max scalar. Here, we use standard scalar method. Step 3. Selecting a cross-validation method among 3-fold, 5-fold, 10-fold, or leave one out to develop the optimal machine learning model. Here, we select 5-fold method. Now we have finished setting up everything needed to submit for modeling. After the modeling is completed, the Auto Nano ML interface will update with new sections for model analysis and prediction. If you are not satisfied with the model results, you can try different parameter combinations to develop a model that suits your own needs. Users can visualize the model results through an interactive scatter plot chart that illustrates the correlations between experimental and predicted values of the nanomaterials involved in the modeling. In addition, they can analyze the nano descriptors by exploring an interactive pie chart that illustrates the contributions of the top K descriptors derived from the modeling outcomes. The interface displays the optimal number of components for developing the best partial least squares regression model, which is obtained from the cross-validation procedure. The R-squared and RMSE are 2 key metrics for users to assess the model performance. The model outcomes mentioned above are downloadable, including the model in pickle format, the scatter plot chart data, and the descriptor contribution data. The updated interface also enables users to upload a nano descriptor dataset of new nanomaterials in XLSX format for prediction using their developed model. Here, we will download and use the example nano descriptor file of some nanomaterials to illustrate the prediction process. After the nano descriptor file is loaded and submitted for prediction, the calculation process begins, and users will receive the prediction results within a few seconds. The linear regression interface provides a workflow similar to partial least squares regression, allowing users to develop linear regression models. The above is a guide for using the Model Toolkit. In summary, VNAs offers a user-friendly modeling toolkit that directly facilitates the rational design of new nanomaterials.